Hey, also, we're making a video here during my office hours because we're having a physics party, and we're going to be talking about workshop number 3, where you have the kid who's kind of hanging off of the wall. I particularly like this problem because I used to do a similar thing in the hallway in my house where I grew up, where I used to crawl up the wall by pushing my back against one side and my feet on the other. But anyway, that's what we got going on here. So here we have this guy, and we need to identify the different forces acting on him. So we know that there's a weight force acting straight down at the center of mass, which is the weight of the guy. And then at the hands and the feet, there's going to be contact forces. And really you can think of that as being two different forces. So at his hands, there's going to be a normal force from his hands, which I'll just call FH, the force at his hands. And then there's going to be a force of friction at his hands as well, which I'm just going to call F1 maybe. It's a force of friction there. And then at his feet, once again, there's going to be a normal force going out, which I'll call F sub F, the force on his feet, and then a vertical friction force, once again, F2. And so really, a lot of people have been asking, is there some force at an angle at his hands and his feet? And the true answer is yes, there's a force at an angle, but the easiest way to think about it and to solve this problem is just to draw the force as an angle as its x and y components, because we know the x component is just going to be the normal force, which is perpendicular to the surface of contact, and the friction forces are going to be the y components, which are going to just be a result, or which are going to be parallel to the surface of contact. So the picture might be a little confusing to see, so I like to just simplify my object and just represent this guy like he's a C or something like that. And so then draw my forces once again. So I have here my weight force, I have up here the force on his hands, and the F1, which is the friction force, and then I have down here the force on his feet and the vertical friction force number 2. So what you can do to try to solve, in fact, is you can start by just looking at some of the forces if you want to. A lot of times that's the easiest place to start. I know we're learning about torque, and so you're anxious to jump into solving torque, and some of you might have done that straight away, and that's okay. But I'm going to start with some of the forces, because those a lot of times are easier and help me organize what I got going on. So if I do some of my forces, I can see straight away in the positive x direction, all we have is the force on his hands, and then in the negative x direction, we have the force on his feet, and that's all, right? So those two combined must equal 0, so you can see actually that the force on his hands is just going to be equal and opposite to the force on his feet. Well, that's cool, but we don't know either of those, so we can't solve, right? So then, next thing I did was I looked at some of the forces in the y direction. So in the y direction, I have F1 in the positive y direction, plus F2 in the negative y direction, or also in the positive y direction, excuse me, and then minus W in the negative y direction. So it looks good, but again, we don't really know what F1 or F2 are, except that we're given the coefficients of friction for each of those, and we know that force of friction is equal to coefficient of friction multiplied by the normal force. Just to remind ourselves, force of friction is equal to coefficient multiplied by the normal force. So in this case, our F1 is going to be mu1 multiplied by the force on his hands, and F2 is just going to be mu2 multiplied by the force on his feet. And we know the force on his feet and the force on his hands are equal, so that's really just one unknown. And doing a little algebra, we can move our W over to the other side. And so what you actually find here, if you look closely at the problem statement, we are given the value for mu1, we're given the value for mu2, I think they're 0.5 and 1.2 respectively. FH we're trying to solve for, and it's equal to FF, so you could actually replace FF with FH if you wanted to. So that's your one unknown, and then what's the weight of the person? Alright, so look at that, live video audience. So it's 52 kilograms multiplied by gravity of 9.8, right? And so right there, you can actually solve for the force on his hands without having to do any sum of the torques. So I'm going to leave that there for you guys to do. And then we're still asked to find what the h distance is.
Wait, is it just one force then for answer 1?
Yes, good. So the question, if you guys couldn't hear, was is there just one force for the answer to number 1? And that is the answer is yes, there is just one force because, as we found with the sum of the forces in the x direction here, the force on the hands is equal to the force on the feet, so it's the same value for both of those. So you just need to solve it once. So in order to find the distance h, I want you all to run from here and try, not run from here, but, sorry, all the students just take off out of my office. No. I want you to take it from here and look at doing sum of the torques equal to 0. I would recommend, you can really choose your location, but based on the distances you're given, all the distances, d, w, and h measured in the problem are all relative to the location of his hands, and so I would do sum of the torque about his hands. So if we use this as our pivot point, then we know there's going to be a torque from w, which would be equal to, if we look at the line of action of w, it's just going to be equal to w multiplied by d. And then there's going to be two torques at his feet. There's going to be a torque from the friction force and a torque from the normal force. And be careful to notice which is the perpendicular distance. You should be able to observe from the drawing up here that h, let me get a new color so we don't get too confused, but that the h value here is the perpendicular distance to the line of action of the force on the feet, and then we have the w that's labeled up here, but that's actually the perpendicular distance to the line of action of the friction force here. So you should be able to do the sum of the torques to solve for h, since you're given w, d, and you now know the value and magnitude of each of the forces.
That's just for his feet, though? Is it for his hands, though, too?
So the sum of the torque at his hands, since we're choosing the hands, yep, exactly, it's 0 since we're choosing the hands as the pivot point. So give that a shot and let me know if you all have any questions.